Anyway, so I am going to continue. I am done with the geometric shapes. So I'm going to continue on the geometric patterns. I'm going to continue on the geometric patterns. Okay. Partly we have learned about geometric patterns, especially when we discuss about patterns related to nature, and partly we have discussed some patterns relate some geometric patterns. No. Okay. So partly we discuss about symmetry and uh, um, some geometric patterns which leads to Fibonacci sequences. No. And okay, so I'll try to focus more on some other geometric patterns, especially on transformations and symmetry. Okay, so when we say symmetry, it's the property of geometric figure for which uh, can coincide with itself. So when we say it coincide with itself, meaning the shape is being preserved, same shape, as well as their measurements are being preserved. No? So if you move the object to the other, uh, the first object, so the image and the pre-image will fit together. So that is symmetry. Okay. So symmetry, it's a form of transformation. No? It's a form of transformation where all its okay, where all its measurements, where are the same. So meaning congruence is being preserved in symmetry. Okay. Again, um, symmetry is a transformation where congruence is being preserved. Okay. So just like the half of the butterfly, ito, so if we try to divide the butterfly into half, its left wing will coincide to its right wing. Ano? So that is symmetry. Okay. Next is a transformation. So when we talk about transformation, it's the changing the size or position of the object. So any image could be altered using different operations or transformations. And they are the following. No? So we have the reflection, rotation, translation, and dilations. Okay. So by the way, class, no, if we try to relate this a transformation, if we try to relate it with matrices and vertices, no, they correspond to a certain operation. No, so let's say for example for translation, a translation is a product of a vector addition. Uh, so yun. Then when we talk about reflection rotations, no, reflection rotations, they are a product of matrix multiplication, where the entries in the square matrix is a trigonometric function. No, so that's that's how we relate transformation with a operations, no, different operations. Okay. By the way, class, no, all symmetry are forms of transformations. Okay. All symmetry are forms of transformations, but not all transformations are symmetry. No, not all transformation are symmetry. So, what are the examples of transformation that are symmetric? So, reflection, rotation, and translation are symmetric because their congruence is being preserved. While for dilation is excuse me. For dilation, uh, the symmetry is not being preserved. Ano, the congruence is not being preserved. Okay, when we say dilate or inflate, so we try to change the size of the object or the shape. So that is why it's not symmetric. So here are some definitions of the different transformations. We have the translation. So when we talk about translation, we just simply slide the object. No, we just simply slide the object. Okay. So what is happening in the translation is that, okay, all points in the object, all points, all movements, all points in the object, when they move, when they slide, okay, all points are parallel to a certain line. No, all points are parallel in a certain line. Okay, and that certain line, we call that as the pencil of parallel. No, if we try to relate that in modern geometry studies, no, so the movement is always parallel to the pencil of parallel lines. So when you call pencil, that is group of lines, no, group of lines. Okay. Reflection, okay, reflection, it's just simply we flip, no? So if you have a book, ano, so this image here, when you try to flip this page to the other one, okay, the resulting image is the reflection, no? That is a reflection. So it is just like you're looking yourself at the mirror. So that is reflection. Then rotation, okay, rotation is just we turn the object at a given angle. Not we turn the object at the given angle. So that is rotation. Okay. For this three, no, if you try to observe the shape, the size of the shape, no, the length and the angle, the measurement of the angle are being preserved. No. So we can say here the congruence are being preserved. That is why these three are all examples of symmetric transformations. No? They are all examples of symmetric transformations. Okay, dilations, when we say dilation, it's we just simply resize the object. No? We simply resize the object. So what is happening in the dilation, though the shape is being preserved, no? The shape is being preserved, so that means the angle and the actual shape is being preserved, but the length, no, are not being preserved. So what we can see here, the length are not congruent, but they are proportional. So that is what is happening in dilation. So dilation is not an example of a symmetric transformation. Okay, then we also have a glide reflection. So it's a combination of a translation and reflection. So what is happening in the action in glide reflection is that first it is reflected, then when it is being translated, the movement is always parallel to the axis of symmetry, or the axis of reflection, no, the axis of reflection. So again, no, first there is reflection, then the translation, the movement of the translation is always parallel to the axis of reflection. So this line here, ito, this line. So the movement is parallel to this one. Okay, we also there are some also symmetric patterns that we usually encountered, no. This is very common in ancient arts, like in Greek arts and also in Renaissance arts, no. The first pattern is the rosette patterns, no. So this is produced by rotating or reflecting a motif or an element of the object. So this is categorized into the following groups. So when you say rosette patterns, it's a composition of reflection and rotation, no? So we have cyclic and dihedral. So when we say cyclic, only rotation is being involved. But when we talk about dihedral, it is both reflection and rotation. No? So cyclic, only rotation is involved, no reflection. But in dihedral, there is both rotation and reflection. So if we try to see this figure here, there is an axis of symmetry here. Kanina axis of symmetry. Also here and that one. So there is reflection involved in dihedral. Then we also have the uh, I don't know how to read this one. It's phrase pattern. Uh, di ba? You have this one in your designs class, no? So this is very common in when you are architectural designs. This is very usually used in architectural designs, especially in kaning what's this? Borders in your kanang door, in the doorway, no? So usahay po sa inyong plates, some of you are using this one, no? Uh, some of you are using some kind of patterns as a border. Mm. Okay, here are some examples and groups, no? So there are some using the purely all translations. There are some with a translation with a glide reflection and so on, no? So here are some groups. Okay, then we also have tessellations. Okay, we also have tessellations. Okay, this is very common, no? Katong mga in the artworks, especially during the Renaissance period, no? Actually, because of this tessellation, the nanganak ang geometry nanganak to another field of geometry, which is what they call the hyperbolic geometry, no? And one of the applications hyperbolic geometry is in physics, no? Especially when you are going to study about space, no? Space. So you are going to study on the hypergeometric space, which is tackled in the hypergeometric geometry, no? So yun, actually it was just an art at first. Then it turns out that it became a field of study, no? So somehow, no, somehow art is somehow mathematics, especially geometry, is kind of related to arts. Okay, here is an example of tessellation. Tessellation is when a shape is repeatedly over and over again covering a plane without any gaps. Let's say, for example, this is the head of a tiger. No, the head of a tiger is being replicated again, and there are some patterns here. Then, if we try to look at each shape, there is no gap in between them. No, no, there's no gap between them, and there are also no overlaps also. So that is it. What is happening in tessellation. Okay, this one is an example of an irregular tessellation, no, because there is no polygon involved here. But if you try to study about tessellation, so when you only have a single regular polygon, that is a regular tessellation. But if two or more polygons is being involved, we call that as a semi-regular tessellation. By the way, you name the tessellation. Now you name the tessellation by the number of sides of the vertices. Okay, the number of sides of the shapes which attach to a certain vertices. So let's say, for example, in this vertex, kaniga vertex, we have a triangle here, a triangle here, a triangle, a triangle, a triangle. So we have 6 triangles, no? So 1, 2, 3, 4, 5, 6. And since each triangle has 3 sides, we name it as 3, 3, 3, 3, 3, 3. Okay. So there are 6 numbers here, which are all three, which represents the number of sides. Okay. In here, okay. So we name this tessellation as uh, 3. Okay, let us try to look at this vertex here. So we can have 3, 4, 6, 4. Okay. You can name it by in either clockwise method or clockwise pattern or in counterclockwise pattern. Now, pwede rin yung mag-interchange, no? Basta as long as the pattern is in either clockwise or counterclockwise. So, pwede ka moingon nga, this is 6, 4, 3, 4. Or you may say 4, 6, 4, 3. Or you may say 4, 3, 4, 6. No? So, that's how we name a given tessellation. So, this is very common, no? Especially sa kanang mga arts. And also, we also see this one in kanang mga tribal works, no? So kanang mga ethnic designs, we also see these shapes also. Okay, so let us try to explore how these geometric designs is being applied in our culture. No. So I guess though we are not familiar with this, some of the tribes here, some of the ethnic groups here in Mindanao, I know some of them are familiar and some of them are not, but we can see that the existence of geometric patterns is being applied in their, uh, especially in their art and culture. No, so we have in the Tibuli. These are the common geometric designs that they have. Tibuli is found in southern Cotabato, no? Kung nakaadto mo og unsa na siya nga lake diya nga tourist spot sa kuan, no? There is a ritual, mag-ritual muna yung Tibuli. Okay, then this is also for the Yakan. Yakan group is somewhere in Davao ata. No? It's belong to Southern Mindanao na group yapon. So we can see some geometric patterns that they have used. Okay, so we also have from the Lanao province, the Maranaos, no? So makita na to sa ilang malong, ano, in their malongs, we can see different geometric designs in their malongs. Then we also have the from the Bilaan. Okay, we also have the Banig from the Tausug people, no? So sa kanilang banig naagya po yung mga geometric patterns that is being used, no? So as we can see here, no, geometric patterns is being widely used, especially in appreciating our culture, no. So makita na to ang geometric patterns is being used by our ethnic groups, no. So historically naa siya and also cultural na nagyapon siya nag-exist. Okay, so we also have some groups here, ethnic groups here in northern Mindanao. Uh, so I guess we some of you are familiar of this. Anang mamistahay sa kamulan, no? Okay, so I guess that's it for our lesson, no? As the continuation of the our lesson last meeting. Okay, class, before I am going to proceed with another activity for today's activity, no? Do you have any questions about today's topic?
Wala, sir.
Okay, wait lang. Okay, if there's none, okay, so we'll try to have an activity, no? So you may respond to this anytime. You can respond to this anytime. Okay, so I want you to ask your parents or grandparents. Okay, so at what tribe or culture you came from, you know? And based on the culture that you came from, okay, post a picture of the geometric pattern that would describe your roots, no? Then leave a message through the link below how this geometric pattern preserve your identity. Okay. Dili necessary nga ko ano, dili necessary that you belong to IPs, okay? So dili necessary you belong to IPs. So I know some of us here are came from uh, urban areas like taga syudad ang uban pero uh, even in Cagayan de Oro naa mo gigyapoy culture ni nag-exist gyapon, no? So not necessary you came from IPs, but if you try if you know much better, okay, if you have known your roots, no, much better. Okay, I'll try to send you the link in our chat box.